Hey everyone, good evening all. Good evening guys, very good evening. Let me quickly share my screen. Okay, yes. So the screen is visible everyone. The screen is visible, the voice is good for all of you. Awesome, awesome. Perfect. So I hope everyone have joined. So we can start. Let me just launch the PPT. My desktop is little unorganized. Please excuse me for that. Okay, let's start quickly. Let me just go to the. Should I go? Yeah, here it is. Yeah. Am I audible, guys? Is my voice clear to everyone? Aditya, now audible? Thank you. Thanks for the confirmation. Thanks for the confirmation, guys. Thank you. Thank you for the quick response. Okay, cool. So the very first thing, let's start with the introduction, guys. Let's wait for a second till this slide got launched. Yeah. Perfect. So the screen is visible, everyone. Awesome, guys. Welcome to the Simply Learn. Welcome to the session. This is the first session for machine learning module, machine learning program. So we are going to discuss complete machine learning in this entire module of the program. So we'll talk about the entire roadmap, what topics, what concepts, how the how each and every concept is divided into different chapters. So we'll talk about that in a while. So as of now, let's start with the introduction. First of all, let me introduce myself. My name is Abhilash Chauhan. I have been working in this data science industry from 5 years now. I'm working as an AI consultant also, and I'm working as a technical trainer with Simplilearn. I have experience in delivering webinars, the workshops, and also we develop tools in different industries like HR, finance, and marketing. Plus, hosting these technical sessions for machine learning, data science, and artificial intelligence. So that was about myself. Anyone have any questions? Anything? Please go ahead. Guys, we'll talk about the prerequisites. We'll talk about everything about the session in a while. Let's start off with the introduction first. Okay, hey everyone. Awesome. So let's move and let me introduce about the Simply Learn. I have total 5 years of experience, including development and delivering the training sessions both. Okay. Awesome. So let me introduce about the Simply Learn. We started in 2009, the very first year of our operations. We started as a project management block. Later on, by the March 2011, we added 4 more categories. By 2012, we expanded with across 50 countries with 20,000 professionals all over the globe. Then by September 2014, we were the largest certificate training provider. By 2015, Simplilearn acquired digital marketing training leader Market Motive. Then in 2016, we were ranked as 8th in the most influential global education brands on LinkedIn. And today, that's 2022, we are the leading global live online training company. So that's about the Simply Learn. Okay, so these are the awards and achievements what we have. These are the awards and achievements what we have received so far. So in 2018, we were awarded with two awards: Stevie winner for customer service and online learning library. By 2017, we also achieved this IT training in like top 20 IT training company. We received an award for top 20 IT training company. That was about the Simply Learn. These are the different sectors in which we are active right now. Our operations are active. Marketing and the automation, full stack development. We also provide the development services, product and processes, and also the data science and artificial intelligence, in which we also deliver the tools and the development plus the training and consulting. Perfect. Now there are a few criteria. Let me just brief you about the course. This entire module, this entire chapter is of complete 45 hours. Okay. So the schedule is like 3 hours daily, 5 days a week, 3 weeks. Okay. 3 hours daily, 5 days a week for 3 weeks. Total 45 hours. Okay. Now in this, we can attend the session by either with the mobile, the desktop, laptop, whatever we have. We have self-learning videos as well to stay a little prepared about what's going to be discussed in the online live virtual classes, what we are doing right now. So we also have the LMS, we have the self-training videos, self-learning videos through which we can get, we can have a little idea and we can get prepared about the live virtual classes, right? 80% attendance is compulsory to avail the certificate. These are the completion criteria, guys. There will be, 80% attendance mandate to unlock the certificate. Plus, there will be simulation exam and project evaluation. So we need to score at least 60% in order to unlock the certificates. So these are the completion criteria. If we talk about the projects, the session end projects, before we jump on the end projects, we will be completing some midterm projects, like we will be discussing the algorithms, the different types of machine learning problems. So apart from the mathematical foundation, the conceptual part of the algorithms, we will practically implement all these algorithms over some business case study, or we'll try to solve some problem, so that we will get some overall, some hands-on experience in order to how do we solve the projects and how do we solve the real-time problems, right? So that's how we'll proceed with the course. Let me know if there are any questions or any things to discuss about the completion criteria, guys. Any passing criteria? 60%. Basically, we need to score at least 60%. If it's about the project, passing criteria is all about the approach of solving a project should be correct, right? So project passing criteria, there is, if we talk about the evaluation, accuracy is not the only metric to evaluate some project, like what accuracy score we are getting, because for the different use cases, the accuracy could be different. Like in some data set, we are getting the best accuracy, that is 60%. In some data set, we are getting the accuracy that is 90%. So accuracy is not the only metric to evaluate the project, though we will observe the approach. If the steps involved and if the approach is correct, that will be approved. Okay. If you stuck at some point, how to reach you, like community, we have the community forum. I hope we must have received the community link and the drive link so far. If not, I'll share you the community and drive link, guys. If we have not received it yet, I'll share you the community and the drive link. Okay, sure. Perfect. So that was the completion criteria. I hope we are all good with the completion criteria for the certificate. Yes, guys. Please let me know if anyone have any questions. No one? Perfect. 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 Is there any books that talks about the theory and the math, or if there is any material? I'll share you everything. I'll share every possible resource that will be required. If you want some book or something, I'll also give you some references. There are some books from O'Reilly Publications, so you can download the PDF version of it, or you can purchase it, whatever feels better. I'll share the link to get that book. Okay, I'll share this. I'll share. Perfect. So let's start with the introduction of the class, guys. So we just need to introduce ourselves by three things: name, years of experience, and if there is any experience related to this course. One thing I would like to add: how we decided to go for a machine learning and data science part, right? So I would just like to add one more question. We can say how we decided, how we came up to start with the machine learning and artificial intelligence. Please. Fresher, no, Muskan Fresher, no experience. Gaurav, Kriti, Sarah, Shraddha. Okay, Kriti, 2 years of experience with coding teacher. Awesome, awesome. Working 3.5 experience in SSIS ETL. Okay. 15 years of experience, Python completed. Awesome, Narendra. Having 10 years of experience in sales and marketing. Awesome. Awesome, guys. Awesome. Okay, I see we have people with more over 10 years of experience, and also we have freshers with us. We have people with entry level experience. Awesome. Completed data science with Python. That's really great. Okay, so we have 4 years experience. Restarted my career. Cool, cool. We take third year. I wanted to go for the data science by being passionate and wanted to make some good money. That's the honest cause. Fresher not completed even a degree. No worries, no worries. Completed Python, no experience. Awesome. 20 years teaching programming, currently doing my PhD using AI in medicine. Oh, that's interesting. Mohammed Gumshali. 10 years, no experience in IT. Machine learning is having good future. That is the reason I'm interested. Makes sense. Fresher with engineering degree. Awesome. MTech first year Vishal, 2.5 years of experience, spacecraft thermal engineer for applying ML to thermal analysis. Okay, cool, interesting. Seema, assistant professor. Awesome. Fresher with geology. 5 years in construction, restarting after a long career break. CS engineer last year. 2 years of experience from Chennai, teaching professional, 18 plus okay, 18 plus years of experience, completed data science in Python, looking for career change option. Correct. 10 years experience in sales and marketing. Awesome. 10 years experience in oil industry, doing PhD. ML is applicable to petrophysics nowadays. Need to learn. Okay. We'll talk about that in more detail. 16 years in marketing and product management, working on a data project as lead strategist through how to understand AI and ML to learn new things. Awesome. 8 years of experience in software engineering. That's really great. Mechanical engineer, experience in crafting, fresher to data science. Okay. Physics and MSc Maths. MCA ongoing, interested in DS, completed Python. Great. Graduate in physics, fresher, awesome. 8 years of experience in embedded automotive domain, no ML experience, average knowledge in Python, learning ML to catch up with technology and both career opportunities. Cool. 2 years of as web method developer. Mm-hmm. Makes sense. Awesome. 12 years of experience in project management. Awesome. Awesome, guys. Nice to have you all. Welcome to the Simply Learn. Welcome to machine learning batch. So it's gonna be interesting. It's gonna be more fun to talk about this technology. So there are few prerequisites, but we will try to get in touch with every basic concept. We are a little limited with the time frame, but we'll try to get in touch with every basic concept and every basic syntax of the Python and everything. So now we can start about the course, about the module. Okay, so there are some ground rules. Let me minimize this chat window. You must be seeing this yellow box. Okay. So some ground rules that will be great to follow to keep the session going smooth. Time punctuality. Make sure we are on time so that we can finish the session on time. We'll be having break every we are starting from 8, so we can have a break at 9:30. Okay. The doubts, most of the times or majority, we will be using our chat box window for the doubt and sessions, right? Doubt and the discussions. In case you need some more, one-on-one talk, and if the question is not being explained by a chat box or the sentence, so we can you can just request to unmute and we can have one-on-one session. But let's try to use the chat box maximum. Then feedback forms. Okay, so once we finish the session, you will get a link popped up, and all we need to do is it's hardly gonna take 2 to 5 minutes. All we need to do is just need to provide a valuable feedback about the content and about the delivery, how it went. And as per the feedback thing, we consider 9 or 10 as a good feedback. Anything below 9 is something is something concerned for us. So if you rate below 9, please do mention what went wrong and where we can improvise. And the last thing, we can reach out to help and support community forum in case of any technical issues, like anything with the LMS, anything we are struggling with joining a session or attendance thing, anything, we can just reach out to help and support. Correct? Perfect. So that's gonna be the last feedback after the end of the session, and that's it for the introduction part. Let's move to the next part, where we will be discussing about the introduction of all these 45 hours, what we are going to discuss in this 45 hours. Okay, now the prerequisites, we need to have some basic knowledge about the syntax of Python, right? We need to know some basic of algebra and statistics, mathematics and statistics, right? So that's the prerequisite. Math and stats is something we can cover during the sessions, but core Python is something we need to know from the prior basis. So core Python syntax is the prerequisite, guys. I will share the resources in case anyone wants to have a quick recap, anyone wants to do a quick revision on the core Python concepts, core Python syntaxes. So I can share the resources, but as we are a little constrained with the time, so we cannot go through with each and every concept of the core Python. We'll start from the data analytics, data science domain. I will share you the resources to revise, to recap the core Python thing. Make sense, everyone? Awesome. Awesome. Perfect. So this module is machine learning certification training. Let's have the introduction, what we are going to discuss. So at the end of the session, once we finish this, we will be able to programmatically download and analyze the data, and we'll be able to learn the data visualization, how to represent the data graphically. Then we'll master the art of data analysis by using IPython notebooks. So have you heard of this IPython notebooks, guys? Do we know what is this IPython notebooks? No? 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 Okay. No problem. No problem. If we know, that's good. If we don't know, let me just tell you what is this IPython notebook. IPython notebook is basically a tool. Yes, that's the Jupyter notebook. It is basically a tool, or we can say an editor where we will write the Python codes and will execute the codes and will be working all the programming stuff in the Jupyter notebook. And when we create a Jupyter notebook file, that is called IPython notebooks. Okay. So in today's session itself, we'll do the environment setup. At the end of the discussion, I'll tell you what all softwares we need to install before we start the coding part and everything. From tomorrow onwards, we'll start the coding and other things, right? So today there will be a little bit of homework, or we can say assignments. We need to do the environment setup, and we need to go through with the core Python concepts, because from tomorrow we'll be starting the data science and recap on the pandas things. Okay. Now gain insights into the role of a machine learning engineer. We'll understand what exactly machine learning engineers do. We'll discuss the machine learning, what exactly is machine learning. So introduction part we'll do it today itself. Work with the industry-based projects, as we discussed earlier as well. We will be working with the algorithms. We will discuss the conceptual part of the algorithms, plus we will discuss the mathematical foundations of all the algorithms, and after that we will try to use that algorithm in order to solve some business case study. All right, that's how we'll proceed with the learning. Learn the tools and the techniques for predictive modeling. So how to make the predictions on unseen and the new data. That's also what we will discuss, what we will learn in machine learning algorithms. Discuss machine learning algorithm and their implementation. Yeah, that's actually what was the machine learning and predictive modeling. Basically all these things we work over the algorithms only, so we'll talk about these algorithms as well. Validate machine learning algorithms means how we can be very sure whether this algorithm is going to give a valid results, or we can trust on the results being written by algorithm. So their validation is also something we'll discuss, and demonstrate the time series and its related concept, how to deal with the time series forecasting and other things. So that's what we will be covering in this entire course. These are the course outline, these are the chapters, and these are the modules what we will be covering. Okay. So first, introduction of the artificial intelligence and machine learning. That is something we'll do it today itself. The second, data wrangling and manipulation, will start from tomorrow. How to deal with the data, how to do the data operations using Python libraries like pandas. Third is supervised learning, regression, and feature engineering, and supervised learning classification. So there will be a little rearrangement here. We will do feature engineering first, and then we will do supervised learning, regression, and classification, because feature engineering is something we implement in supervised and unsupervised regression. So that is being utilized in those learning algorithms. So we'll do feature engineering first, and then supervised and unsupervised. Okay. So there'll be a little rearrangement. After the data wrangling and manipulation, we'll do feature engineering, and then we'll do supervised learning for classification and regression. So that's how we'll proceed. Then we'll do unsupervised time series forecasting, ensemble learning, recommendation system, and text mining. So what is supervised and what is unsupervised? Though we will talk about that in more detail, but as of now, I'll give you a quick brief of it. Supervised machine learning, when we have something in supervision, means something what we need to predict is something we already have with us, so that we can supervise the machines in order to learn. That is called supervised machine learning. But when we don't have the target, what we need to predict, we don't have that with us, that's called the unsupervised learning. For a very basic example, let's say I want to learn how to drive a car. Now I have someone who already knows how to drive a car and he can guide me. That's a supervised learning. Someone is supervising me. But if I try to learn how to drive a car without any supervision, with all of my experiments, that's called unsupervised learning. So we'll try to see how we implement supervised and unsupervised learning algorithms and methods with the machines, right? Time series modeling is all about dealing with the time indexed data like stocks, weather, and these examples. Whenever the data is indexed with the time unit, so that is called time series modeling, how to deal with the time series data. Ensemble learning is basically when one algorithm is not giving a good accuracy, we combine multiple algorithms together and create one strong learner. I'm so sorry. So sorry, guys. Okay. I'll try to make the pace a bit slow. So sorry. Okay, so we are good with time series. We are good with time series, guys? Perfect. 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 So we were discussing the ensemble learning. Now, what exactly is ensemble learning? Ensemble learning is basically when we try to combine multiple algorithms in order to create a strong algorithm. That is ensemble learning. Suppose we are trying to solve some business problem, and we tried individual algorithms and we are not getting desirable results. So we combine multiple algorithms to get a strong algorithm so that we can achieve whatever is required. That's called ensemble learning. We'll see how we do it. Correct? Perfect. Perfect. Now, recommender systems. Dheeraj, you didn't missed much, but we were just talking about the introduction, and we are talking about the basics first, and we just had an introduction. That's it. Yeah. So right now we haven't discussed much technical concepts. We are just discussing the basics, and we just had the introduction about the class. Okay, that's what you missed. Okay, cool. Now we understood the ensemble learning. Now the recommendation system, recommender system. These are basically the system what we experience in e-commerce websites. When we purchase something or when we rate something, we start getting the recommendation of other products, right? That's called the recommendation systems, recommender systems. And the last chapter will be text mining. Basically, how do we deal with the text data? How do we deal with the natural, documents, the text like messages, emails, all these kind of things? So how do we deal with that type of data in machine learning? That is the text mining. So that will be the last chapter of this entire course. Understood? Let me know if anyone have any question or anything. Text mining, like if we talk about this 10th chapter, text mining, this is going to be all about how to deal with the text data, right? How do we store, how do we process, how do we utilize the text data for getting a solution or improving some operation, right? What is basically mining? Data mining is if we specifically say mining is all about collecting data in an organized manner. That's the mining. Data science is art or science? Okay, good question, Nikita. Data science is art or science? Though it's called a science because it has certain rules to follow, but it is an art because which rule to use in what case, this is something we gain over experience only. So though it's a science, data science, because science we have certain rules to follow, right? Why it is called data science is an art? Because which rule needs to be picked on what kind of data, what kind of problem statement, that is something that is something we call as an art of modeling, because this is something we gain over experience only. There are certain good to follow rules, but there are bunch of exceptions where those good to follow rules they does not make any sense. So it's a science, we have rules, but which rule to implement in what case is the art, right? Correct. I can't hear you. I'm so sorry. Am I audible to everyone, guys? Awesome. Thanks for the quick response. Perfect. So that's gonna be the basics. That's gonna be the outline of this course. What we will be discussing in this entire 45 hours. Now, this is the prerequisite, guys. These are the prerequisite. Linear algebra, that is something we should know. Statistics is something we should know. And Python. Okay, so Python is something that is the must prerequisite, because linear algebra and statistics is something we can cover during the session, right? So we can discuss the basic linear regression, linear algebra and statistics during the session. But Python is something that we cannot complete in this, we are constrained with the time. So Python is something we should know. In order to do a quick recap, I'll share you the resources. So the only one prerequisite to attend this course is a basic Python syntax. That's it. Okay. Data science with Python certificate course we have completed. Okay, so everyone have completed data science with Python? Awesome, awesome guys, awesome. Awesome, awesome. Then it's good. Then it's good. Then we are good to go. Awesome, guys. Awesome. Okay, so we must be following some program like some entire program in which machine learning is a specific module for that program, right? Because I often get the batches where we have mixed learners. Few people have the background, few people do not have the background. That's why I just confirmed. No problem. If we have done, it's good, more than enough, guys. If we have touched it, if we have gone through it, we are more than enough. Okay. Awesome, guys. Awesome. Then we are good to go. Okay. So these are some projects what we will be doing at the end. So we will discuss it later on. These will be the our these are our end session and projects. So we'll talk about them. And that was the introduction only. That was all about the introduction. Okay, so now we will discuss the basics of machine learning and artificial intelligence. But before we talk about the basics, let me tell you what all softwares we need to download and what all reference links we should be referring while doing this program. So let me share you the drive link and other things. Just a second. Yeah, I got it. Okay, this is the drive link, guys. Please keep it handy somewhere, store it in a bookmark, save it in a bookmark, store it in a sticky note, or place it in some notepad somewhere. Please keep this drive link handy because we will be sharing all the possible resources using this link only. Okay. But in data science with Python, we didn't get real projects, or why? I can't say anything about the other batch, guys. I'm so sorry. I can't say anything about what was the case in the batch of data science with Python or something. I'm so sorry. The drive link didn't work for me. Why? Like, is it saying some error or something? It's like it's empty as of now. Oh, sorry. I let me share it again. I'm so sorry. Let me share it again, guys. Okay, got it. I copied it from the email actually, so that's why the colon got copied. Yeah, here it is. Please use this one. Here it is. Please use this one. And I've also shared the community link here. I have posted the community link here. The community link is also there. So please keep these two links handy. Okay. Apart from these two links, let me share one more link. That is my personal drive, and there also we have the resources for machine learning, but that is little unorganized. Excuse me for that. Means it's not like day one, day two, or day three like this, but we have good enough resources in that drive also. Okay, now this link what I'm sharing right now, this link is not specific for this batch only. That's my personal drive, and we have the complete machine learning resource from zero to advanced. Everything is available, but it's just little unorganized. Means it's not like day one, day two, day three, day four. It's with respect to the topics. So there are folders that explains the topic, and inside that folder we have the resources. So you can keep this also. This has way more resources available for the machine learning and also for the deep learning and other things, right? And what I have shared earlier, that is specific for this batch only. Okay. So I'll keep on updating day to day files in this in that other Google Drive. Okay. Community link. I haven't shared the community link. Wait a sec. Yes, here it is. Done? Okay. So I have shared three links, guys. Let me again make it, there could be a little confusion about the link. I have shared three links, two Google Drive and one community link. Okay. Three links. There is one drive link that belongs to the specific batch only. For this batch only, right? So there is date mentioned in that drive link for this batch only, right? Where the date is mentioned. Okay. And another drive link, that's my personal drive link 2. The name is Simply Learn ML Content. The name is Simply Learn ML Content. Okay. ML Content. So that's a general drive link. A lot of people are referring to this link. So I'm not going to erase it anything from there. A lot of people are referring to this drive link, and there is a lot more resources about the machine learning is this in the second link. And the third link, what we shared is the community for this batch. Okay. Right. So we shared three links as of now. Okay, so guys, please save all the three links somewhere as a bookmark, or you can paste everything in a notepad anywhere, whatever you feel good, or whatever is handy for you. Please save all the things to avoid any type of confusion in further sessions, right? Awesome, awesome. So the resources are done. What's next? The software is what we are going to use. So everyone have access to the LMS, right? We have access to the LMS, guys. Awesome, awesome. So in LMS, we have this self-learning tab in which we can go through with what we are going to discuss in the live sessions. That's the self-learning tab, live classes through to attend the live virtual classes. Then we have practice lab. Okay, so in case we have not installed Anaconda and everything in our dedicated system, we can use this practice lab. Now there is no compulsion that you have to use practice lab or you have to use the Anaconda dedicated Anaconda environment. There's no compulsion, guys. It's up to you. Whatever is more feasible, whatever is more you feel like whatever is good, you can go with that tool. So we have options. We can either use this Jupyter Lab, this practice labs from LMS. We can install the entire setup in our own dedicated system, that is the Anaconda. I'll share the links and everything, how to install and set up the Anaconda. Apart from these two options, we can also refer some other cloud platform like Google Colab or IBM Cognitive Labs, anything. It's completely up to you guys. Okay. Is Spider IDE more helpful? Okay, so guys, which tool is good, which tool is better? This is completely subjective from one individual to another individual, right? Oh, I'm so sorry, my screen was paused. Yeah. Now again, everyone can see my screen. Thank you. What is the difference between Anaconda and Python? Anaconda is a environment, guys. Anaconda is not a programming language. Anaconda is an environment that will provide the all possible resources to code with the Python, like IDEs and the libraries. So Anaconda will give all the possible resources. It's basically an environment, a virtual environment in our systems. So that's the Anaconda. Yeah, toolkit for data science. And Python is basically a programming language, a tool necessary for the data science. Perfect. So we can use either Jupyter Lab, we can either install the Anaconda, or we can go with some third-party cloud lab like Google Collaborative, Google, Google Colab, yeah, Google Colab. We can use Google Collaboratory, or we can use IBM Cognitive Labs. We are free to use any tool. Yeah, that can also we can do. So if we say that's completely we can write our tools, we can write our applications in Spider, also in Django, in PyCharm, also in Jupyter. Also, it's completely subjective from one individual to another individual, right? Someone which has more experience working with Jupyter, he will be more comfortable on Jupyter, right? Someone which have more experience with PyCharm, he'll be more comfortable with the PyCharm. So which tool is better, which tool is good, that is a debatable topic, and I feel this is subjective thing. Make sense? Awesome. Now this is all about the environment and the tools required. Let me share the link for the Anaconda also. Here we have. So you can use this link if anyone wants to install Anaconda. So just go to this link, download this environment for your respected operating system, install it, and we are good to go. Okay. Perfect. Now we can start the introduction about machine learning and introduction about the artificial intelligence. Before Jupyter will work, right? Yes, anything will work. I'll be using Jupyter, but if you want to use Spider or any other tool, it's up to you guys. We are free to use any tool. Okay. Okay, so this is the lesson one of this course, where we'll be discussing the introduction part of what is artificial intelligence and what is machine learning. So before we start the introduction, guys, anyone wants to ask any question, anything before we start this discussion? Please. Now, any suggestions or anything before we start? Nothing? Okay. What format? I'm sorry, I didn't get by the format. From Python, do we need pandas knowledge alone? We will be doing the recap on pandas. If we know, that's good. Yes, video format will class recording be in. The video format is a specific format. I exactly didn't remember the format, and that can be played on NVR player only. So you will get a no, actually, that's something we cannot handle. Personally, I can't be able to take care about the recording extensions. This is something technical team handles, right? About the recording extensions and what will be the format of recording videos. That is something technical team takes care of. So we will be getting, yeah, that ARF extension, and that can be played using NVR player only. We can download that player from the LMS itself. Once the recording is ready, you will get the link to download the player as well. Yeah, thanks Rahul, thanks for these steps. According to experience, people who are switching career to the data science. Rohan, nothing else you need to do. You just need to put some more efforts in practicing. Let me tell you about my experience in teaching. I get lot of queries from the learners that we understand the things during the sessions. We understand the logic, we understand the code, we understand the approach. How do we solve it? But we face difficulty while we implement those things. I get hundreds of such queries. I would say 90% of the people who are new to the programming, they face this challenge that we understand during the session. We understand the logic, we understand the code, we understand the approach, we understand everything. But when it comes to the implementation, we face difficulties. This happens. How do we overcome this thing? By the practice only, right? More we get our hands dirty with the code, more better we get the grip. So even if we understood whatever we discussed during these 3 hours of session, it's must to revise and re-implement the same thing by our own. That's the only way to get a grip, and that's the only way to build up more hands-on experience about the coding and solving the problems. Right? Make sense? So just make sure that we are doing the regular practice. That's more than enough. Anyone, if you are fresh, if you already have some prior experience, this small thing, make sure what we have covered in 3 hours of session, we revise the same thing, we re-implement the code, the same thing what we have done in 3 hours, again by our, again by ourselves only. So that is something must. Even if we are not doing something extra, we are good. But what we have covered, we need to revise that. That's more than enough, guys. Perfect, guys. Okay, now let's start the introduction. Sure, guys, sure. Are you going to teach AI also, or AI ML are combined? We'll discuss what is AI and what is ML. Like in half an hour or so, we'll discuss, we'll understand what is AI, what is ML, what's the difference and everything. And I will be taking care of this module only, that is the machine learning certification course, right? There'll be machine learning and certification course. So I'll be taking care of specifically this module as of now. In case I get something aligned for deep learning or NLP, that could be a possibility, but I can't say anything about that right now. Please also provide interview type questions in between the sessions. Definitely we'll discuss all of them. And from where to practice Kaggle projects, definitely we can refer the Kaggle projects. Plus we will be sharing the resources. We will also be sharing the resources and everything for the practice. No, for today we won't be doing any coding. As of now, we'll be talking about the basics and the introduction. The coding part will start from tomorrow. Okay. Awesome. Perfect. So the first introduction. So what will be covered in this slide? Machine learning techniques and applications of machine learning. That's what we will be discussing. And the objective for this first chapter, for this first lesson, to define the artificial intelligence and understand its relationship with the data, define machine learning, ML, and understand its relationship with artificial intelligence and data science. Okay, and we will discuss understand machine learning approach, identify application of machine learning. Okay, so that's what all written and that's what all mentioned in the slide. Let's discuss apart from this slide. Okay, the keywords, same order of self-learning presentation. Yes, we are following the same order. If there is any change, I'll let you know. If there is any rearrangement, I'll let you know. Okay, as of now we are following the same order. Perfect, guys. So first of all, the two major booming keywords in the industry right now, machine learning and artificial intelligence. So let's start from the intelligence, artificial intelligence. If we break this keyword, artificial and intelligence, right? Now, intelligence is something, what like that is something we refer to a human intelligence, right? Now, What do we understand by this intelligence, guys? What is exactly, if I say some XYZ person is intelligent in some industry, what exactly this means? What is intelligence? Knowledge. Okay. Yes, guys. Like right now, nothing technical. Just in general, what do we understand by intelligence? Right decision. Yeah, that's what I'll pick. Right decision, thinking ability. Correct, Nikita. Cluster of information that actually gives intelligence. That actually gives intelligence. Solving problem, clever, right decision, thinking logically, right, competence and problem solving in multiple ways, right, analytical thinking, right. Okay, so see guys, intelligence, analytical thinking, or this analytical thinking thing cannot be applied in everywhere. Like someone is intelligent in sports, right? So there'll be the decisions will completely depend on the states. So in short, in general, we can say the intelligence is all about thinking ability, right? Intelligence all depends upon the thinking ability. We think and we take right decisions on a right use case, right scenario, right situation, right? That's the intelligence. It could be in any domain, it could be in any field, any industry. Intelligence is all about thinking abilities, right? In short, we can simply say intelligence is all about thinking abilities. We humans are intelligent because we can think. Make sense? Yes, guys, we can simply say intelligence is all about the thinking. We can think, that's why only we are intelligent, right? Right? Okay. Now, if we try to implement the same thing, ability to think, if we try to give the same ability to machines, that's called artificial intelligence, right? If we try to give the same ability of thinking to the machines, that's called artificial intelligence, right? Yes. Now, in order to make the machines think, if we want to make the machine think, we need to understand how humans think. Then only we can implement this thinking ability to machines. We understood artificial intelligence is all about making a machine think like humans. Okay? But if we want to make the machine think like humans, we need to understand how humans think. And we can think, we can take decisions after learning only. Make sense? We cannot think if we don't learn, right? We won't be able to think, we won't be able to respond if we won't learn. Our thinking, our action taking, whatever, completely depends upon our learning, right? Yes, guys? We right now we are trying to understand how humans think. So we think over learning only, right? Yes, yes. And learning is what? Gathering information from past experience is, the experience is the best way to learn. But what exactly is learning? Just gathering information. We gather information and that's the learning, right? Yes. So, if we talk about humans, the human intelligence is all about thinking. And with think, we can only be able to think over learning. We can learn and then only we can think. And what is learning? Gathering information, right? We gather information, we learn, and we can, based on that information, we can think and respond. That's the process. Yes, that's the process. Understood, everyone? Awesome. And then we give, when we apply the same process to machines, it's called artificial intelligence. Now this process has the stages. In order to make the machine intelligent, we need to make the machine learn first, right? And that's called machine learning. And when the machines are intelligent enough to take their own decisions, that is called artificial intelligence, right? In order to make machine intelligent, that is artificial intelligence, we need to make machines learn first, and that is called machine learning. And in order to make machines learn, like how do we learn? We learn by gathering information. We need to give information to the machines, right? That's called data science, where we work with the data. Giving information is what? Giving data to the machine. And that's dealing, managing that data is called data science. Understood? What is the relationship, this data, machine learning, and artificial intelligence, guys? Easy? Perfect. Perfect. So now we got the backline. What exactly is this entire, data science, machine learning, and artificial intelligence? Now let's proceed with the slide. What's mentioned in the slide? Data science, gathering information for learning, creates ML. Right, right. Or not only gathering, we also need to treat that data. We need to process that data and all those things. That comes under the data science only. ML is a subset of AI, right? Perfect. Now there is a very, very good question. Why this data science and ML and AI thing got this sudden boom in the industry from last 4 or 5 years itself? If I tell you that the algorithms, the techniques, the mathematical concepts, what we are using right now to build an AI or to build, a machine learning, they have been introduced in 90s itself. But what makes the big giants to work on the machine learning and data science right now in last 4 or 5 years only? Because the generation of data, the size of data. We have generated a huge amount of data as www, World Wide Web, increased. Yes, www got a popularity, right? People started moving to the internet. Most of the business operations are running online right now. This innovation of different types of management systems available online right now. So we started generating a lot of data, and that generation of data gives a lot of opportunity to work with the data and to create some innovative tools, innovative products out of that data. That's why this data science, machine learning, and artificial intelligence is getting a this sudden boom in the industry. Make sense? Right, right. And now, apart from this, there is one more cost, that is the availability of hardware resources. If we talk about 90s, we cannot process trillions of data in efficient time, right? But right now we have available such hardware resources in an affordable costing that we can, process huge amount of data set over, complicated algorithms in efficient amount of time and efficient costing as well, right? So that's also a good, a big cause why this data industry has grown this rapidly in 4 or 5 years itself. Make sense? Yes, guys, make sense? Okay, that's the basic thing. Emergence of artificial intelligence. What's written? Science associated with the data is going towards a new paradigm where one can teach machines to learn from data and derive a variety of useful insights, giving rise to the artificial intelligence. And that's what we discussed, right? We have the data, so utilizing that data, we can make a machines learn, and that learning derives the artificial intelligence, right? Easy? Awesome. Then artificial intelligence refers to intelligence displayed by machines that simulates human and animal intelligence. Yes, and that's what we discussed, right? Artificial intelligence is nothing. It's just the intelligence what we, what we have, the ability to think, and that's something we try to give to the machines, and that's called artificial intelligence. Easy? Perfect. Now, some artificial intelligence tools in practice. So we all are aware about the self-driving cars, Tesla, Elon Musk, right? Siri, and OK Google. And there are a lot of such Alexa, and there are a lot of such virtual assistants that is also an application of artificial intelligence. Yeah, AlphaGo, the chess playing applications, Amazon Echo, Alexa, and the robot, right? Humanoid robot. So these are some applications that we experience these days about the artificial intelligence. Then sci-fi movies with the concept of AI. So we have experienced a lot of movies as well that explains the possible applications and the possibilities of technology and artificial intelligence. Though I'm very bad in these movies and fictions, so I don't even know the name of these posters. X Machine, the Terminator. This one I've heard of, Terminator, but rest of all other posters, I don't know about these posters. But yes, seen all of them. Awesome. But yes, the fictions, the movies are explaining a good possibilities about the technologies, right? Have you heard of Neuralink? The company founded by Elon Musk, they are trying to improve the reaction time in humans. Yes, yes. Test done on monkeys, yes. And I think they got the approval, they got the permission to test on humans as well. Not sure, but yes, they got the permission. Yes, they have created a chipset to be installed on human brain. They have created a chipset to be installed on a human brain, and that's gonna improve the reaction time of humans. But I'm little I don't see this as a very productive tool, because if this got if this is actually something going to happen in future, so no one is going to take interviews. They'll only ask which version of the chipset you have installed in your mind. So I don't know what they are thinking, and what where we are heading. True. Okay. Now, data facilities and recommendations. Yes, we experience these recommendations, and sometimes they are quite irritating also. You just text someone that we are looking for a trimmer, and you'll start getting the ads of trimmer everywhere. So that's also an, yeah, it helps. Obviously, it helps, but sometimes it's irritating also. Even if you will purchase a trimmer, you'll get the delivery. After that, also you'll keep on getting the advertisements. There should be a way to tell these recommendation engines, okay, I bought this product, stop giving me the recommendations now. True. Yeah, yeah. If we the stores and the marts are the old school way of recommendations, right? If we remember, in the very the very beginning of the grocery shopping, it was we go to a store with a list, we hand over that list, and the shopkeeper will give us those products, right? That was the very traditional way of shopping grocery. We go to the store with a list, and we hand over the list, and we get the products. That's how we used to shop in old days. Gradually they thought of an idea that we should place the product and let the consumer walk throughout the store and pick the products. Now, what is the idea, what is the concept behind this placing the products? Suppose I want to buy some snacks, so I'll go to the store, I'll go to that section where the snacks are there, and there are huge number of snacks. So if I wanted to buy one, I can buy more than one, because I am getting recommended by the other snacks also, right? That was the beginning of these recommendations. And gradually we have online recommendations. Like if everything has gone to cloud, we are doing shopping online now. So we have online recommendation engines, right? Even after registering, I saw ads for more than 2 weeks from Simplyland. Happens. Even I used to get ads from Simplyland itself, and also from other vendors. Okay, so that's also some application of data science right now we can experience. Now, okay, this is a little technical flow chart about artificial intelligence and machine learning. Yeah, so I'm getting X. I joined months back. Clear your cache. If you are using some web browser, clear your cache and browsing history. You will stop getting ads. Applies to your smartphones as well. Clear the cache and browsing history. You'll stop getting ads. We can always trick an artificial intelligence. So because they are machines, right? They are machines. We can always trick them. I saw few paid tools. Uh, yeah, I saw few paid tools. They have trial of 14 days, and after 14 days, if you clear your cache and history, you'll get the trial version again. But yeah, they have upgraded this by now. But in the beginning, that's how their trial version works. They give 14 days of trial, and after 14 days, clear your cache and history, you'll get trial again. But now there are lots of there are lots of uh, corrections to these kind of loopholes now. Okay, now let's discuss this flowchart, guys. It has a little technical terms, but let's try to keep it more simplified. Right now, we won't be discussing more technical terms today because we are just talking about the introduction. The problem will happen when they will trick us. If you know the AI, you can't be tricked by an AI. How can we say data science will be trained as today after 5-10 years? See, we are generating data, but if you ask me personally, the future is the metaverse, right? And data is going to play a very important role in the metaverse, right? Because if you observe the trend, the big industries, the big companies are investing heavily in metaverse. Though the resources to make this metaverse commercial right now are quite expensive, but there was a time where internet was very expensive in India. There was a time when internet was very expensive, and lots of things that we are using today, they are part of our lives. We cannot think of utilizing those things with this frequency. Yeah, we can say geo, or we can give, and obviously geo is a huge cost, but ultimately if there were no geo, some other company must have stepped in and they made internet quite accessible. So there was a time when internet was not this cheap and this much accessible to everyone, but right now we have a lot of things accessible, and we have a lot of applications, lot of such tools that are part of our life right now. So similarly, the tools to access the metaverse are quite expensive, but I would say in 5 to 10 years, the metaverse is going to be part of our life like internet is today. Can we have a question chat after some time or completion of the few slides? Makes sense. Makes sense. I agree, and I'm so sorry. We skipped the exact path. Today is the first marriage held on metaverse. Not aware of that. Okay, let's keep this discussion for the end. Let's discuss the slides, guys. I agree. We are we are diverting from the topics what we need to discuss. Okay, let's come to this artificial intelligence, machine learning, and data science. So we discussed when we try to make a machine learn, when we try to make a machine intelligent, it's called artificial intelligence. When we try to make a machine learn, it's called machine learning. And the processing of data, the preparation of data is called the data science to make a machine learn. So there is a small flow chart here. The process, the entities, and everything is included. And this is trying to explain the difference and the relationship between these terms. Okay, so some technical terms are there, like what is unsupervised learning, what is deep learning, what is supervised learning, and data transformation. Okay, so let's see the very first block, that is the data. We all know what is the data, right? Yes, guys, we all know what is the data. Every piece of information is a data. Now, not every piece of information is going to be helpful, so we need to extract the important information about the from the raw information, right? We need to extract the important information from the raw information, right? And that important information is called features. Got it? There is a data, a raw data, but not necessarily that every piece of raw data is going to be important. So we extract some important data, important information from the raw data. That is called features. So how do we extract these features? Either we do some manual transformation techniques, or we follow some machine learning algorithms, that is unsupervised learning, to extract the features. Okay? Understood? What is a feature? Raw data, raw info, transformation data, extract feature, right? Either we transform them manually, or there are some automated learning algorithm that can extract the features. So either way we can go with. Now we can utilize those features to make the machines learn and get the predictions, right? We can utilize those features to make the machine learn and get the predictions, right? This is supervised learning. Sure. Features, basically the data is the raw data. Not every piece of raw data is important to us. To extract the only relevant information from the raw data is called feature. How do we extract the feature? Either we can do some manual transformation, or we can follow some automated learning algorithms like unsupervised learning. So that will give us the feature. Correct? Perfect. Understood, guys? What is the feature? What is the data? Now we can use that feature to make a machine learn, and we can get the predictions from the machine, right? And there is also a branch coming from directly data to the predictions. So there is a branch of learning that is called deep learning, through which we don't need to extract the features. The deep learning will just use the raw data. It will take care which is important, what is not important. It will only use the important and make the predictions. Right? Yes. So we can get the data, we can get the predictions from either supervised learning method. So from the machine learning, supervised or unsupervised, whatever we can say, from the machine learning method, we need to extract the important features. But when it comes to the deep learning, it can take the raw data and make the machine learn. Correct? NLP is covered in deep learning, not exactly. Deep learning has some application of NLP, but NLP can also be done using machine learning itself. Okay. Yes. Okay. Now, are we good from data to prediction, everyone? What is unsupervised, supervised, deep learning? Are we good from data to prediction? Machine learning, we haven't covered this box yet. What we covered, data, extracting features, utilizing those features to make a machine learn and get the predictions. So either we can go this way, or we can simply use some deep neural networks that can use the raw data, extract whatever is important, and it will remove what's not important by itself and make the machine learn. And that's how we can get the predictions, right? So from data to predictions. Good till here? Any questions? Anyone? All good from data to predictions? Okay. Now, if we observe this dark red, orange, or whatever color it is, if we observe this specific dark box, that is what explaining the machine learning. So in this specific area, we are trying to make a machine learn, right? In this specific area, we are trying to make the machine learn. Make sense? Yes, guys? Okay. Now, from the predictions, we can analyze and calculate and get the insights about the predictions manually and take some decision also. For example, let me give you an example, guys. Okay, we were working on a public sector domain once, and like UNESCO, UNICEF, MDA, Medina Development Authorities were our clients. They used to provide us surveys, and we need to utilize the data on the survey to target some indicator. Okay, so once there was a scenario, we have suicide rates in African regions, right? So there are some sort of survey that tells us about the suicide rates in Africa, and we need to write some we need to build some good strategy in order to take care of this specific indicator, that is the suicide rate. So suppose we have the survey, data is the survey. Okay, we have the survey that has a huge amount of data, in which something is good, something is bad. The data is in a proper structure, some columns are not very they are not in a proper structure. So we have this raw data, we have a survey. Now from that survey we extracted the meaningful information that's going to help us in order to get information about the suicide rate. That's the features, and to attain the features we can either go with the unsupervised learning or the transformation, anything. Make sense? Yes, guys, make sense? Awesome. Awesome. Perfect. Now, based on those features, we trained a machine, and the machine started giving the prediction on the suicide rates. Okay. We utilized the features and we trained our machine. The machine will start predicting the suicide rates now. So right here at this stage, the machines are predicting us the suicide rates. So now how we are getting predictions? Either some supervised algorithms, or we can use some deep learning algorithms, anything, but ultimately we have the predictions from machines. Clear till predictions point? Yes? Okay. Okay. Now here is the catch about machine learning and artificial intelligence. If we analyze the predictions and we get the insights from a manual analysis, let's say some analyst is observing the predictions and he's trying to understand what are the factors that are impacting the predictions, like the literacy rate, the population, or the employment ratio. What exactly are the factors that are impacting our predictions? We are trying to analyze the factors, and we are making a decision that we should invest on education, we should invest on employment to reduce the suicide rate. So there is someone who is analyzing the predictions, carrying out the insight about whatever is the problem statement, and making a decision. So if some human is involved to carry out the insights, so now this is an analysis. That's why this process is covered under the data science part. Analyzing the predictions and carrying out meaningful insights is a data science part, because we are manually analyzing the data, right? Make sense? We got the predictions, we are trying to analyze the predictions, we are trying to get some meaningful insights, and this is what we are dealing with the data. We are analyzing the data. That's why it's a data science part. Make sense? Yes, insights. And based on that insights, we take a decision that we should invest on employment, we should invest on we should invest on literacy rate, education. That's a human decision. But now, when we have the machines capable enough to interpret, to debug the predictions and recommend the actions where we should invest, that's the artificial intelligence, because there is no human intervention. Human is not involved here. The machines will make the predictions, and based on the predictions, machines are debugging those predictions. Machines are actually interpreting those predictions and recommending us the decisions, what we should do in that case. That's the artificial intelligence. Got it? Yes, guys, understood everyone? Perfect. So we got this flow chart, guys. We got this diagram, what is data science, what is machine learning, and what is artificial intelligence. And we can see the artificial intelligence box is also covering the machine learning, because we can only make a machine intelligent once the machine is learned, right? AI is taking actions automated. After we get the predictions, those predictions are being analyzed by the machines itself, and the machines are telling us what needs to be done. That's an automated decision, right? And that is the artificial intelligence. So taking decisions after learning is called artificial intelligence. If we relate it to the process in humans, We learn by gathering the information, and based on that learning, we think and we respond. We take decisions based on the learning. Similarly, that's where taking decision takes place in the artificial intelligence. We learned, and based on that learning, we take decision. Basically, machines take decision, and that is what the artificial intelligence is, right? Okay, what is deep learning? Preeti, anyone would like to answer what is deep learning? Though we haven't discussed very detail about the deep learning, but we just talked about what it does in this diagram. Anyone? Yes, guys. Anyone wants to answer what is deep learning? What this branch is doing in this specific diagram? It takes straw and predict. Yes, yes. Means it will decide by itself what data is important and what data is not important. Right? Deep learning will make the machine learn by the raw data itself. It will decide which data is important and which data is not important by itself. So in artificial intelligence, we don't make any insights. No, and that's what the artificial intelligence is, because it's intelligent enough. It can learn and it can improve. So we don't need to, we don't need to interfere. Artificial intelligence means it will learn and it will improve. It will take its own decisions. We don't need to interfere. An automated vehicle will learn and improve. We built a software once where there was an agent who can throw emails to the prospect, and gradually the software will learn which type of email is more fruitful to get the responses. So more we utilize that software, more better emails it will start sending. So it is gradually learning over its experience, and that's what the artificial intelligence is. What's the difference between unsupervised learning and the deep learning? Unsupervised learning and the deep learning is completely different. Unsupervised learning is actually right now, if I talk about this figure, we are presenting unsupervised learning to extract the data, right? This is one application of unsupervised learning, extracting meaningful information about the data. That's what we can do from the unsupervised learning, but unsupervised learning can also be utilized in lots of other cases as well, right? In case of deep learning, it selects the important data by itself, and also it trains the machine. It will make the machine learn also, but that is something unsupervised learning cannot do. AI, DSML belongs to same domain. Yes, they belongs to same domain. Or if I say AI, ML is actually the data science only. See, what is it? To make the machine intelligent, to make the machine learn, we need to work with the data. We need to apply some scientific methods over the data, and that's the data science itself. So in general, we can say data science is a huge umbrella that covers all data related technologies, be it computer vision, natural language processing, machine learning, or whatever it is. So data science is a general term. Whatever scientific method, whatever scientific algorithm we apply over the data to achieve any objective, to make a machine learn, to make a machine intelligent, whatever it is, that's the data science. Correct? And there is one more benefit of these domains, that they are not industry specific. If you learn data science can be applied in marketing also, data science can be applied in finance also, data science can be applied in sports also. So it's not industry specific, right? Yes, guys. What about reinforcement learning? Where does it stand with the respect to other learning algorithms? I'll explain about the reinforcement learning. The approach to make a machine learn in reinforcement learning is little different. Okay, got it. Deep learning is an automated using algorithm to extract the most appropriate feature using raw data and unsupervised, where algorithms are used to extract the required features. Right, exactly. Correct. Okay. So we are almost headed to the break now, but let me quickly brief you about reinforcement learning, guys. How reinforcement agents work. They take actions, they observe the response, they observe the feedback, and based on that feedback, they will decide whether the action was good or not. And that's how they will improve. That's the reinforcement learning. For example, we want to train a robot to move from point A to point B. Okay, let's understand this way. We want to train a robot. We are writing a software for a robot controller in which the robot will move from point A to point B. Now, in order to move, there are possible actions. Take a step slowly, right? Take one step slowly or take two steps aggressively. So there are different states also. If the robot is at a static position, it's standing, it should take a step slowly. But if the bot is already moving, it can take two steps aggressively. Make sense? Yes? If we want to make a bot, if we want to make a robot to move from point A to point B, so we need to decide the actions. So possible actions are, let's keep two as of now only. Let's consider there are only two possible actions what we are considering: taking one step slowly or taking two steps aggressively. If the bot is standing, bot should take one step slowly. If the bot is already moving, it can take two steps aggressively. Make sense? Now see, the action depends upon the initial state of a bot. What action should bot take depends upon the initial state of the bot, right? What is the initial state? Based on that, the bot will take an action. The controller, what software we are writing, that will recommend the action with respect to the current state. Now, how this is being learned, how the controller will learn which action to be taken on what state. To learn, it will explore. This algorithm is called exploration and exploitation, right? This is called exploration and exploitation. So during the exploration phase, the controller will explore different actions on different states and it will observe the outcome. So at a standing position, if the controller is taking two steps aggressively, the bot will fall down. And it's a wrong feedback. It's a negative feedback. The action was not good. That's why the bot fell down, right? So that's how reinforcement learning works. It will explore the different actions on different states and it will observe the outcome. Based on the outcome, it will learn the policies, which action to be taken on what state to achieve the objective. That is the reinforcement learning. Yes, guys? Understood? Awesome. So now there's a break time. We'll take a break and we'll proceed from the slide only. Okay. So there'll be a polling activity. Let me start off with the polls as well. Guys, the pace is good. We are going good. Everyone? Yeah, I'll keep the timer also. All good? Perfect. Let me put on the polls as well. Awesome. We should enjoy the learning. 15 minutes. The polls are open, guys. The polls are open. And let me put the timer also. Yeah, this is the timer, guys. Awesome. Let's get back after 15 minutes. Hey everyone, we are all back now. Awesome. Okay, let's resume. So we were at the slide. We need to finish the slide and we will be able to finish the slide today. Awesome. So relationship between artificial intelligence and machine learning. Okay, so we had already discussed what is the relationship, right? Yes, guys, what is the relationship between artificial intelligence and machine learning? Yes, AI is all about taking the automated decisions, right? AI is all about taking the automated decisions. ML makes the predictions, which is used in AI for producing actions. Right, right, right. Yes. Anyone, how difficult AI is? Sorry, I didn't get your question. Difficult in sense to learn. Okay, again, this is subjective, right? As it is difficult, it is easy. That's subjective. I would say it is easy. I would say it's not difficult at all. Nothing is difficult if you put right efforts and right approach of learning. If you do right, if you do enough practice and if you put enough efforts, nothing is difficult, right? So I won't say it's difficult at all. It's very easy, right? Okay. So relationship between AI and ML. Is it clear? Yes, guys. Is it clear? Perfect. Definition of machine learning: the capability of artificial intelligence system to learn by extracting patterns from the data is known as machine learning. Now, what this statement explains basically how we exactly learn, how the machines will exactly learn. Machines will try to extract the patterns in order to learn, right? Now, what kind of pattern? Let me explain the pattern here as well. Suppose we know that we are carrying a huge amount of information in our mind, right? We know a lot of things. Yes, guys? But if someone will ask me, what's your name? I'll respond with my name only. Right? If someone will ask me, what's your name? I'll only respond with my name. Though I have a lot of information with me, I am carrying a huge amount of information. But the mind is having this neural network, the mind is actually having, detecting the pattern, what kind of information needs to be returned on what kind of input, right? Yes, what needs to be returned as an output on what kind of input. That's the pattern we are talking about here. Make sense? So if someone will ask me my name, I'll respond with my name. If someone will ask me the second law of thermodynamics, I'll respond with second law of thermodynamics, right? The pattern is, though I am carrying a huge amount of information with me, I'm carrying a huge amount of information in my mind. But if someone will ask me what is your name, I'll only respond with my name itself. I will not respond with second law of thermodynamics. I'll just respond with my name. Exactly, exactly. So machines will try to detect this pattern. What should be, what output should be given on what input. Easy? Okay. Let's move to the next slide. Features of machine learning. Now, this is something new to learn. It uses data to detect the patterns in the data set and adjust program actions accordingly. That is something we had already discussed, right? The machines, we will give the data and machines will try to understand the patterns, adjust the patterns, and based on those patterns itself, it will make the decisions, make the predictions, right? Easy. The first point of the feature, output depends on input, definitely, and also the data, right? If it just action isn't there, okay, so if there is only hard coded action, a rule based action, that's not an artificial intelligence. For example, uh, an ATM machine, so it takes an input, it returns an output, but that is something hard coded. The ATM machine is not learning over experience. That's why it's not an artificial intelligence, right? So that's the difference in approach of a traditional software and an artificial intelligence or a machine learning software. That is something we will be covering in upcoming slides. Okay, okay. Now it focuses on the development of computer programs, that are the softwares, that can teach themselves to grow and change when exposed to new data. Okay, now point 2 and point 3 needs to be explained together. Let's try to understand again what it says. It focuses on the development of computer programs. Computer programs are actually the softwares that can teach themselves to grow and change when exposed to the new data. Means, let's take an example of the next word recommendation in our smartphones. So when we type an email, when we type a message, when we type some, text or some email, we get recommendation of what can be our next word, right? Right? Yes, we get the recommendation on what could be our next word, the next word recommendation. Okay. So have you ever noticed, let's say, I have some client that is in marketing industry, in marketing company, and I'm writing a lot of emails that is having the marketing terminologies, right? So right now the software is learned to recommend the terms included in marketing industry. Possible? Now after some time I have some new person and he's in finance. So I started writing emails or text that has lots of terms related to the finance. Gradually the software, the next word recommender, will learn those terms in finance as well, and it will start recommending me the terms included in finance also. So when I exposed this software with the new data, it started learning and improving itself. Right? Make sense? Correct? So that's what the second point is trying to explain. Now the third point is telling that in order to improve or in order to get, see, if I relate this example with the third point here is, the software is recommending me the words related to the finance without being explicitly programmed. Means no one changed the software. No one have updated the codes in the software. right? Without being explicitly programmed. No one is changing the software, but still software is capable enough to learn from the new data and start making actions as per the new data. Correct? Yes, guys? So we are not programming or we are not updating the software. We are not changing the tool. We are not doing anything. The program, the instructions, what are written in the software are still the same, but they have been written in such a way that when it is exposed to the new data, it is learning and it is recommending and taking actions based on its learning. So it's learning by suggesting the appropriate values and understanding how the user uses it. Exactly. Exactly. He's learning our typing pattern. He's taking the information, he's storing the data, what kind of messages we are, what kind of emails we are writing. The tool is trying to learn the pattern, and based on the new typing, based on the usage of new terminologies, the tool is also learning those terms, and he will start recommending the new terms. So that's a feature of machine learning without being explicitly programmed. We are not programming the tool, but it's still able to learn the new data. Correct? That is how the machine learning is different from traditional softwares. That is how the machine learning is different from traditional softwares, right? Example, the same example about the next word prediction. We took this example for understanding these features of machine learning only. The next word, the recommendation in our smartphones is an example of machine learning software itself, right? This will learn the new terms and whatever the new terminology we are using as per the different people in different industries. When this software is exposed to the new data, it is also learning the new terms and new terminology, and it will also start recommending us those new terms without being explicitly programmed. Correct? Awesome. Understood? It automates analytical model building. Okay, now this is something we'll talk about later. Like what is analytical model building and how these analytical model building are being automated. That is something we'll discuss later on when we'll talk about the machine learning algorithms. Awesome, guys. Understood? Great. Okay, now here is the difference in approach. Now this is a little confusing, so apart from this, let me use the whiteboard in order to understand the approach. Okay, see, when we write a standard software or when we write a traditional software, what we do? So we write some rules or some instructions, right? I would say rules. We give input, and based on these rules, we get the output. That's a traditional software, right? We write these rules, and the software will take the input based on these rules. The input will be processed, and we will get the output. That's the traditional software, right? Yes. We must have studied the first chapter in computer uh, in computer science, input processing output flow of a software. There is an input, there is a processing, and then output, right? Now the programmers, the people like us, write these softwares that we are referring to rules as of now, and that's the approach of a traditional software. That's how we write a software. Excuse me for the bad handwriting. Traditional software. Okay. Now, yeah, set of instructions. Now, how it is different from machine learning? See what happens in machine learning. We have the data. Okay. Now data includes the input and also the output. Okay, data includes the input and output both. We gave this data to some machine learning algorithm, some machine learning, method. I will simply mention it as ML algo. Okay. This machine learning algo will try to detect the pattern from this data and it will generate the rules. It will generate the rules. And if we give input to these rules, it will give the predicted output. Predicted output. That's how the machine learning model is different. A machine learning software is different from a traditional software. Correct? Easy? Easy? And see, these algorithms are so much flexible. When we give some new data to these algorithms, it will improve the predictions, right? These ML algorithms are so much flexible. When we will start giving new data or more data, the rules will get updated to make better predictions. Yes, improves accuracy. That's how the machine learning softwares are different than traditional softwares. Easy? Cool. Cool, guys. Cool. Okay, that's the difference in the approaches. Now, okay, yes. This is the traditional approach and machine learning approach. So we understood this in easier way, right? This looks quite tricky. This looks quite tricky, but we understood the machine learning approach and the traditional approach, right? Everyone got the difference? Perfect, perfect. So let's proceed. Relationship between machine learning and the data science. This is also something we had already discussed, but let's see what's mentioned in the slide. Data science and the machine learning goes hand in hand. Data science helps evaluate data for machine learning algorithms. Also, not only evaluate, data science also helps to prepare and the process data for machine learning, right? Data science also helps to prepare and process data for the machine learning, and that's what we saw in that specific flow diagram as well. Yes, perfect. Understood. Now let's see what's next. Relationship between machine learning and data science. Okay, now there is some technical explanation about the relationship. So in machine learning, the statistical measures what we use. If I try to explain it, okay, when we say this is ML, this is some ML algo, there are some statistical methods behind this algorithm, right? And some parameters of those statistical methods are deciding during the, like, these are the rules are basically the parameters of these ML algo. We'll talk about in more detail, we'll talk about this in more detail when we will reach to the algorithms and the mathematics, but right now I'll try to keep it as much as simplified. ML algorithm have some statistical methods, right? We work with some statistical methods behind the ML algorithm, and statistical methods have some parameters that can be tuned to improve the accuracy, right? The parameters can be improved, it can be reduced, increased, or they can be tuned to improve the accuracy. The right value of those parameters are the rules what we use to get the accuracy. Make sense? Yes, guys, make sense? The ML algorithm are working over some statistical methods, right? And statistical methods have some variables. If we talk in mathematics, they have some variables. And the right value of those variables are giving us some accuracy. And those variables needs to be tuned. We call them as a parameters, right? So a statistical method have some parameters that needs to be tuned in order to get the best accuracy. Now these statistical methods are some methods that we also use manually not to automate the algorithm, not to train a machine. We also use it manually to get some meaningful insights from the data. So that's also something similar in data science and machine learning. Yes? Make sense? Yes, guys, make sense? So post auto tuning these parameters, algo create rules. Yes, and that is the rules are basically the right values of the parameters, right? ML algo try to tune the values, and rules are basically the right value of those parameters. And these statistical methods, what are included in machine learning, we also use these statistical methods for analyzing and carrying out the meaningful insights in the data, carrying out the relationship between the data. So that is what relationship, that is what something common in data science and data science and machine learning. Understood? Easy? Yes, guys? Though this is little technical, we will talk about this complete step in more detail with derivation of the statistical methods and what variables we are talking about. But right now we are just talking about the basics, the introduction. So I try to keep it more simplified. Okay, so that's something similarity between machine learning and data science. I hope this is clear. Next, statistical machine learning uses the same maths and techniques as the data science. That's what we discussed. These techniques are integrated into algorithms that learn and improve on their own, right? So if we see, the statistical methods are integrated with the algorithm so that they can learn and improve. The statistical methods, the statistical algorithms, what we are using, that can be used manually to carry out meaningful insights, and that can be integrated with the algorithm to learn and improve. So that is also something common between data science and machine learning. Make sense? Make sense? Overall, these 4 points what mentioned are revolving over the same concept. That is the methods what we use for the manual data science, and the methods or the statistical methods that are being utilized in machine learning to automate the algorithm are common. Right? Understood? Yes, guys. So the first 3 points, if I just try to summarize, the first 3 points mentioned here, they are trying to explain that the statistical methods what we use in machine learning to automate the learning are same, are common, what we use in manual statistical analysis also. Correct? Like linear regression. We try to calculate the beta coefficients in linear regression to get the impact of every column to target variable. If we know the linear regression, in linear regression, we try to calculate beta coefficient statistically to understand the impact of every variable to target variable, and we use the same linear regression to minimize the loss to get accurate predictions. Right? Right? So when we say we try to calculate beta coefficients to understand the impact, it's a statistical method. When we say we try to tune the beta coefficients to minimize the loss to get more accurate predictions, that's machine learning. Make sense? Though the algorithm, the statistical method is same, that is linear regression. Perfect. Now, the last point, machine learning facilitates artificial intelligence as it enables machine to learn from the patterns in the data, and that is something we have been discussing so far. That machine learning will give artificial intelligence. It will give rise to the artificial intelligence. Could you repeat the last statement? Sure. About the linear regression, right? So in linear regression, we have beta coefficients. When we try to calculate the beta coefficients in order to get the impact of every predictor to the target variable, that's a statistical method. Yes. statistical modeling. This is called statistical modeling, when we try to calculate the beta coefficients in order to understand what is the impact of every variable, every predicted to the target variable. But same linear regression, same beta coefficients, but this time we are trying to tune the beta coefficients in order to optimize the loss and to make the more accurate predictions. That's the machine learning. Correct? Awesome. So, understood about the relationship between machine learning and data science, guys? Awesome, guys. Awesome. Let's proceed. And these are the machine learning techniques. Now, these are not only the machine learning techniques, there are a lot more, but these are the major techniques. So, there are 8 techniques, 7 techniques. So, let's discuss these techniques. What exactly are they? First of all, classification. Anyone have any idea about what is classification? Yes, guys. Anyone, any idea about what is classification? Yes. Grouping used for categorical data. Categorical data. Predicting something category, and that is classifying some observation to a class. Let me take a very, no, categorization is different than classification, guys. Categorization is different than categorization. Okay. Let me pick some example. See, we are working on cancer detection. So the end product, what the end product is doing, end product is trying to classify a new patient into a respected class. What are the classes? Healthy or cancer affected, right? Try to understand. Example, a business case where we want to predict whether a given patient is having a cancer or not. Okay. Small example, we want to predict whether a given patient have cancer or not. So what is going to be our end product? End product is trying to classify a new patient into a respected class. And what are the classes? What are the possible classes? Either 0 or 1. This is the classification. Easy? Dividing a category into subcategories is class. No, it's not. That's not the classification. Limited to 2 options and categorization is more. No. It's not like this. No, it's not like this. Classification, even if we have more than 2 classes, that's also the classification. Okay. Let me explain what is categorization. Then then we'll get the difference. Categorization is categorizing some continuous entity. For example, converting marks to grades. That is the categorization with respect to the bins, right? Converting the marks column to grade column. That is called categorization. We have a continuous entity. We categorized it by creating the bins. That is called categorization. Yes? Understood? What is categorization, guys? Categorization is simply grouping, or we can say creating the bins of some continuous entity is called categorization. Creating bins on a continuous entity is called categorization. But classification, based on age, definitely we have the age. Age is what? Age is a continuous entity. If we create age groups like infant, baby, adult, teenage, whatever, we can create the groups. This is called categorization. Creating salary slabs, categorization, right? Yes. When we convert a continuous data to category using the bins, that's called categorization. Right? When we convert a continuous variable to a category by utilizing the bins, by using the intervals, that's called the categorization. But classification is completely different. For understanding the classification, let's take this example of detecting cancer in a patient. So we have trained our model. We did all the required stuff. And what is our end product? The end product is predicting whether a given patient, a new patient, is having cancer or not. So what exactly it is doing? It is classifying the new patients in a respected class. And what are the possible classes? 0 or 1. That's the classification. It's it sounds similar, but see, in case of classification, it's not necessary to have a continuous entity, right? Yeah, and also we are having a new observation, and there is nothing like something continuous is necessary, or we are using bins, we are using intervals. These things are not there in classification. Yes? But if we talk about categorization, we are actually creating bins. We are actually using intervals on a continuous variable to make it category. The result into pass or fail is classification or categorization. It's classification, right? If we are predicting a new, okay, now again, this depends. Again, this depends. Why I said depends? The result of pass or fail with respect to what? The result into pass or fail with respect to its mark is categorization. The result into pass or fail with respect to its activities, how many hours the student is spending for games, how many hours the student is spending in, its day schedule. If we are predicting whether the student is going to fail an exam or he is going to pass an exam based on the activities, that's a classification. But if we are making pass or fail with having the marks, that is the categorization. Now we got the difference. Good example. You gave me the good example. Suppose the getting either the student is going to pass or fail an exam. If we already have the marks, so that's the binning only. If we already have the marks, there is only interval thing to say whether it's fail or pass. If we already have the marks, right? Yes, guys. If we already have the marks to decide whether it's fail or pass, we just need to make intervals and we can easily get it. Make sense? Yes, this is called categorization. This is called categorization. But if we don't have marks, we have day routine of the students. How many hours they are spending for study, how many hours they are spending for play, how many hours they are spending for all different activities. And based on those activities, we need to predict whether they will pass an exam or they will fail an exam. That is called classification. Understood? Got the difference now? Everyone? Easy? Awesome. Awesome. So we understood the classification and categorization. Categorization. The third is clustering. Clustering is grouping with respect to every piece of information we have. If we group with some specific target, that will become classification. But when we try to group with respect to every property available in the data, that's called clustering. Let me take an example again, because without example we won't be able to get it better. When we suppose we have the customers, okay, we are working with the e-commerce platform, we have the customers. Now we want to group our customers based on their behavior. Means we know what they are buying, when they are buying, what they are liking. And when we consider every property, their monetary factor, how much money they are spending, the category of product they are preferring, the frequency, how frequent they are, when we consider everything and we try to group them with every possible property we have, that's called clustering. But when we group them with some specific factor, let's say we want to group it with respect to the monetary, means how much money they are spending, that is not the clustering there. That is classification, because we have a specific target in that case. But when we don't have any target, we just group it based on their behavior. That's called clustering. Easy? Yes, guys? Easy? Again, without data, how we classify a person will be healthy or cancer patient? If we talk about a supervised machine learning, we need to have the data. We need to have the data to train the machine learn first, right? To make the machines learn first. Once the machines are learned, then only we can predict. So again, if you observe the approach, we have input and output both to feed in to the ML algo, right? So this is the medical conditions. Input is the medical conditions of the patient, and output is whether they have cancers or not. We gave the entire data. Machine learning algorithm will try to detect the pattern on which input, what is the output, and based on that, it will set the rules, and these rules will make the recommendations, make the predictions whether a new patient have the cancer or not. Yes, got it. Perfect. So clustering is making the groups of the data. Means group of no, not group of classification. No, not the group of classification. Just making the groups of data. That's without any target, without any respected target is called clustering. Because when we have the target, that will become the classification. When we don't have the target, that will be the clustering. Make sense? Grouping the data without any target is clustering. But when we have the target, that will become the classification. Okay? Understood? Perfect. Okay, now fourth point, trend analysis. The name itself is explaining what is the technique, right? Trend analysis. What do we understand by this name? Anyone? Trend with market. Trend with anything. It could be any trend, right? Like in stock trading, yes, in stock trading, we refer to the trend to make a good trade, right? In stocks, in cryptos, a lot of people are getting more interested about the cryptos. So we refer to the technical indicators, and those technical indicators are the trend analysis only. Yes, guys, they are the trend analysis and everything only. Correct? What is the trend analysis? Trend of the data where it's leading. Exactly. Understanding the trend and making the decisions based on the trend. Exactly. Helps in understanding the past and the current status to get an idea of the future behavior. And predicting the future will become the forecasting, right? Perfect, guys. Understood trend analysis? Sure. The trend analysis is all about observing the trend and having some insight about the future, the past, the present, and based on the past and present, we get some insight about the future. That's the trend analysis. Easy? Awesome. Now, the fifth point that is again quite interesting, that is the anomaly detection. Detecting the odd ones, right? Anomaly detection, detecting the odd ones. For example, outliers. Detecting the outliers is called anomaly detections. And what are outliers? Outliers means the the observations that are not following the normal distribution, that are not following the normal trend out of the range, right? Out of range data, correct. Yes. So anomaly detection means specifically detecting the odd ones. Easy? Understood what is anomaly detection also? Yes. So visualization, we also know what is a visualization. Anyone wants to tell what exactly is the visualization, guys? Graphs, basically graphical representation of data. Exactly, graphical representation. Graphical representation. Yes. Perfect. Decision making is all about analyzing the results and take a proper decision to achieve the task or to achieve the objective, to solve the problem or to improve the revenue, whatever is the requirement. Decision making is observing the results, observing the trends, and to make a right decision. Right? Perfect. Applications of machine learning. Okay, before we proceed applications, the techniques are clear, everyone? Sure. Clustering is basically grouping the data without the target. Clustering is all about grouping the data without the target. Means, for example, we have the customers. Let's say we have an e-commerce client and we have the customers. We want to group the customers based on their behavior. There is nothing specific on what factor we want to group. If we know we want to group over a monetary factor, then that is supervised. That is classification. But if we don't have some factor, some targeted factor on which we should group, that's a clustering. We just have the audience. We need to group them based on their behavior. Every piece of information what we have, we need to utilize that and we need to group them. That's the clustering. Right? Perfect. Example of decision making? Sure. Remember the example of what was that? Suicide rates in Africa. So based on the factors and the predictions, we will make some decision where we should invest and what indicator we should invest. Should we invest in education? Should we invest in employment? Should we invest in cleanliness or whatever it is? So that was the decision we used to make based on the predictions and based on the insights what we carried out after the entire analysis, right? Example, algorithm. No algorithm will make the decision, right? Algorithm will give us the predictions and we need to make the decision based on that predictions, right? There will not be any algorithm that will make the decision. Yes, guys? Perfect. Understood the slide, guys? Perfect. Okay, now the applications of machine learning. Now, image processing, robotics, data mining, video games, text analysis, healthcare. So these are different industries. These are different, types of applications where we can implement our machine learning techniques. Okay, so decision making doesn't sound like a technique. It sounds like a action taken. Yes, actually, basically, this is what we do when we call, when we work with the machine learning, right? These kind of things, what we often do when it comes to the machine learning implementation, right? Understood? Got it? We got the sense of that entire technique. Decision making tree, no, that's the decision tree. That's different. That's different. Decision tree is different. It's a classification and a regression algorithm. We'll discuss about the tree when we'll do the supervised learning. Okay, that's different. Okay. Text analysis, when we deal with the textual data, the documents like emails, reviews, the sentiments to calculate whenever we work with the textual data, that's the text analysis, right? So these are the possible applications, like applications of machine learning. The first one is the image processing, auto face tagging in Facebook. That's an application of image processing. Self-driving cars, optical character recognition. That's the image processing, right? Mining. So sorry, you mean to say text processing? Data, we haven't reached the data mining. We'll proceed, like, let's go one by one. Image processing, then robots. Let's go one by one. Okay. So the first was image processing and the possible applications that what we can experience as of now. The auto tagging feature of the Facebook. It's doing the image processing. It's detecting face, and it's recommending the auto tag, right? Self-driving cars are also processing the images and taking the actions. Also, optical character recognition, reading the text from the image. That's also the application of image processing, right? Understood? What is image processing, guys? Perfect. Then robotics. So we all know about the robotics, human simulation, humanoid bots, and industrial manufacturing bots. There are lots of such robotics application that are currently in application right now in lots of different industries and domains. So we know about robotics. Then yes, we can proceed, guys. We know the robotics is clear. Awesome. This is the application, that is the data mining. Now data mining is all about collecting and analyzing the data for making for any XYZ objective, to increase the revenue, to make the business operation more efficient, or to minimize the risk, to mitigate the losses, whatever it is. Whenever we collect and we analyze the data, that comes under data mining. Web scraping is actually a black hat technique to gather information from websites, but that is something black hat. Black hat, I mean to say, I won't say it's although illegal, but web scraping is something we try to access the information from the website. Yes, unethical. Yes, it's unethical, but it's very, it's a practice in the industry. So a lot of people used to do this. Ethical is when we have permission from a given website, from a given provider to access their data. That is only ethical. And lot of websites give us the APIs to access the data, like Twitter. Twitter has the API to access every data from Twitter. Google Finance have the API. Yahoo Finance have the API, right? See, data mining is all about collecting information, and there are different mediums to collect the information. Data mining is all about collecting the information, and there are different mediums to collect the information. Extraction is one possible medium to collect the information, right? Understood? Yes, guys. So when we, sure, data mining is all about collecting information, gathering information, and there are different mediums to gather the information. Where data extraction is one possible medium to gather the data, gather the information. Okay. Now, what was data mining? Data mining is all about having the data, collecting the data, understanding, analyzing, utilizing that data for some XYZ objective. Like anomaly detection also comes under data mining, grouping and predictions also comes under data mining, association rules like recommendation engines also comes under data mining. So this everything is the data mining. Correct? Easy, guys. Understood what is data mining now? Gathering and utilizing the data for any XYZ objective. Easy? Perfect. Then video games. So there are different video games in which machine learning is being applied. For example, the Pokemon Go, though I haven't played this game. Then after the video games, it's a possible application of a machine learning. Text analysis. In text analysis, we work with the text data. What exactly is the text data? For example, emails, right? See, spam filtering the spam emails, spam messages is text analysis. Now, sentiment analysis, whether a given review or a given comment is positive or negative. Yes. So we can build such tools, we can build such softwares that can analyze the text and carry out the insights about those text. That's called sentiment analysis. So that is also the text analysis, because a review, a review, a comment, it's a text. And when we try to build a software that can understand the text, that's called text analysis. Information extraction, what exactly is, okay, the very good example of the information extraction is search engines. When we search for a keyword, it only gives results based on that keyword only. If we'll search for a iPad in Google, it will only give the results related to the iPad, nothing else, right? So that's the information extraction based on the text itself. Yes, guys? Understood? Text analysis? Perfect, perfect. Okay, healthcare industry. Healthcare industry is a huge platform for the application for the machine learning practitioners. A very huge platform, guys. There are bunch of startups, there are bunch of innovations, bunch of applications that are being introduced in the healthcare, right? I have heard of a possible application. There was a news about Google. They are building something that can scan the, like the smartwatch kind of device that can tell around 16 or 26. There was some number of factors about your blood. They were trying to build some, software like this, some machine learning software like this, that will have the same sensor what we used to have in fitness trackers, and that same sensor will extract the information about our, like whatever information it extracts, and the software will try to get 16 or around 26 factors about the blood. So there are lots of things happening in healthcare industry. Make sense? So these are possible different applications. Yeah, even in farming. So as we said, this machine learning, this data science is not some industry dependent. It's not restricted to some industry. In whichsoever, yeah, exactly. In whichsoever business operation we are having data, we can use machine learning. We can use data science, right? Awesome. So that was the entire introduction, the key takeaways, what we understood about this. The explosion of data has given rise to the new economy that is known as the data economy. True. Now, AI refers to the artificial intelligence and machine learning that simulates human intelligence. And yes, that's what we discussed. The capabilities of AI systems to learn by extracting patterns from the data is known as machine learning. Yes, that's what we discussed. Statistical machine learning uses the same math and techniques as data science, and the artificial intelligence and the machine learning are being increasingly used in various functions such as image processing, text analysis, healthcare, data mining, robotics, and video games. So this was the overall summary of this entire slide. Yes? Any questions? Anyone? Any doubt? Anything to ask about this first introduction? All clear? All good? Awesome. Waiting for the coding? We'll start coding tomorrow. Or if you are waiting for the more interesting stuff, it could take 2-3 days, not more than that. because tomorrow will be a bit of recap about pandas. We'll do the pandas itself tomorrow. If we are waiting for more interesting stuffs, like when we will start working with the mathematics and all, it's gonna take 2 3 days. What will be the available roles in the market after learning this ML? There are lots of things, guys. Yeah, there is a little bit of confusion in the job market also. So I won't say go with the job title, go with the job descriptions, because I have personally observed in somewhere it's mentioned data science practitioner, somewhere it's mentioned machine learning engineer, somewhere it's mentioned data science professional. So there are lots of different keywords, lots of things that are actually having the same context. So go with the job description, what kind of skill sets, what kind of technologies they are asking. So what we will be able to go for after this entire course: machine learning, data science, natural language processing. These are the major three things that we will cover. Okay. We need SciPy and Matplotlib knowledge for ML. Guys, these are the libraries. And libraries are what? Libraries are just the tools. To understand, ML is a technology. ML is not a tool. SciPy, Matplotlib are just a tool for the visualization. Let's try to understand the tool and the technology. Suppose I want to reach to some XYZ location, right? So that my objective is to reach that location. How do I reach that location? I take a flight, I take a train, I take bus, I go with my own vehicle. These are the mediums, these are the tools to reach that location. Machine learning is a technology, it's a technique, it's a concept. How do we implement it? We have some tools, we have some libraries to implement that machine learning. The Matplotlib, SciPy are basically the tools. They are the libraries to do the visualization, to implement the mathematics over the data, right? So it's actually not required to have full-fledged knowledge of the tools. Until and unless we know the tricks, we know the concepts, we know what are the mathematics that we are going to utilize, we are good. Make sense? How much is the knowledge of cloud technology are important, like Azure or AWS? Rohan, very good question, very good catch. The cloud, how much cloud is important? Like, to be very honest, it's not very much important, but yes, it is a very good plus. It is a very good plus if you are applying for any job, because today or tomorrow you have to work with the cloud technologies. If you are a machine learning practitioner, if you are working on machine learning models, data science, or anything, today or tomorrow you have to work with the cloud. But again, this is not prerequisite, or this is not something must what most of the companies are looking. But again, it is a very good plus. Could you give what is the difference between cloud and normal? Cloud, basically we deploy some model to some remote, or we can say we deploy our model to some remote to some remote desktop or some cloud server, where anyone can access that tool, anyone can access that platform with the IP of that specific cloud server. That's the only difference. When we install some software, when we build some software and we run it on our own system, only we can access it. But when we make it public, we deploy it on some cloud server, anyone can access it using the IP or the URL we link to that IP. Yes. Could you please give some examples, real life applications of the human resource and ML? Okay, sure. Basically, we are currently working on a tool that will basically ML based and AI based engine that will screen out the best candidates for a given job profile. Because let's say for us, our database has across 33,000 active candidates. Active candidates, not dead audience, active audience. They are currently seeking for the job on a very active basis. So if there is something, if there is some role posted by any XYZ vendor, so top 50 candidates will be surfaced by the application itself and will be forwarded to the vendor for a given job. This is an possible application of ML in human resource, right? Statistical machine learning, basically when we talk about the machine learning, we follow some statistical methods. For example, linear regression. And when it comes to the linear regression, we need to have beta coefficients, right? And in beta coefficients, There are two ways. If we calculate the beta coefficients to get the impact of predictors to target variable, that's called statistical method. We follow some statistical rules to calculate this. But when it comes to the calculating beta coefficients in order to optimize the loss in prediction, that's the machine learning. Now this is little technical. This has some technical terms. We will be able to understand it more better when we'll actually implement this linear regression. Correct? Yes. Awesome. Anyone? Any other questions, guys? Are you from? Sorry. You mean to say my background or? In finance banking sector, portfolio management can be done using ML, right? Trading can also be. Which state? Actually, I'm from India. Portfolio management can be automated using machine learning. Plus, there are lots of trading algorithms also in the market. But honestly, I have spent years, or I won't say years, so I have spent months in automating the trading algorithms using ML and AI. And this is something we like. It's just a good portfolio or resume kind of project, but it's something that's not very efficient when it comes to the real time trading. So we were able to get it to some extent, but that was not only ML. There were lots of different technologies included to get a product to some extent. Right? Lots of I saw this thing. I have experienced this thing. Lots of people are very interested in automating the trading. To automate the trading, we can automate the crypto trading using machine learning and artificial intelligence. But honestly, we have spent months in doing this, and ML is something, or like ML is alone. ML cannot achieve this thing. How it can be detected in fraud detection? It can be applied in a fraud detection. Possible ways: classification is the one way. Second, anomaly detection is the one way. Because the fraudulent transactions are completely different from the usual transactions. So the anomaly detection is the possible way. Or if we already have some collected data about the frauds and the genuine transactions, we can use the classification also. I have heard that 90% time is consumed with preparation of the data while working as a data analyst or engineer. That's true. That's true. We need to spend 90% or most of the time in preparation in the preparation and the pre-processing of the data. That's true. And that's where we call it as an art of data science, right? Implementing algorithm is no big deal because algorithm is actually the science. They have the straightforward rules. They will process the data as per the rules. They have few parameters. We again have the rules to tune those parameters. But what kind of data, how the data should be pre-processed, how the data should be prepared for what algorithm, that's where we call it as an art. Okay, got the idea about the fraud detection, how we can achieve fraud detection in ML. Two possible methods: anomaly detection, right? Two possible methods: anomaly detection, because the fraudulent transactions are quite different than usual transactions, so they can be detected as an anomaly. Other than that, classification, if we already have the information about like collected data about the fraudulent transactions and the genuine transactions, so we can go with the classification also. I'll give you I'll give you some practice case studies on fraud detection. Yes. Yes, guys. Anything else? Anyone? Because that's the most crucial part of the entire step. Making a machine learn on a given algorithm It's not a big deal, right? Because algorithms are straightforward. They have certain steps to follow. We will give the data and they will give us the result, whatever they are capable of. We can not do much with the algorithms, but we can definitely play with the data structure, the format of data to make the model more accurate. Yes? Make sense? If it comes to the algorithm, the best we can do to change and different just to change and just to try on the different types of algorithms. What are the difficulties you faced in AI? Now, again, what kind of difficulties we usually face completely depends upon what kind of project we are building, right? Sometimes we are limited with the data. Sometimes we are, okay. And now let me tell you a very unique use case, though we are running with the time, but let me just tell you one most worst difficulty what we faced so far. Okay, so we were trying to predict the direction and the magnitude of a specific trend. Okay, let's say this is the trend of the price of some asset. Okay, this is time, and this is the price. Okay, so we try to build an algorithm that can give the magnitude and the direction for some time stamp. Let's say at this point of time, we look forward for 3 units of time and we try to predict for 2 units of time. Okay, this is the current time t. We look forward till t minus 4 and we try to predict for t plus 2. That's what we were trying to do. Okay, suppose we build this algorithm. Now when we try to predict in this same sequence, when we try to predict, when we try to give the data like this and we try to predict for the upcoming next timestamp only, we were not getting a good accuracy. But when we flush this, when we shuffle this, like this is the time series data, and we try to eliminate the time factor, we just try to understand the data trend, we eliminate the time factor, we shuffled this data and we try to make the predictions, we were getting brilliant accuracy. But when we preserved this pattern, we were not getting accuracy. So these kind of challenges we might face in different types of problem statements. And that was one of the worst challenge what we faced. Only the different data distribution, like either you are preserving the data in same sequence or you are having the data shuffled, that was having a huge impact in the accuracy. Right? So again, we definitely have different types of problems, different types of challenges when we work with the data and the different use cases. Let me give you one more example. Let's say we are detecting the cancers. Not a lot of people have the cancers, right? So suppose we have 1000 samples and out of 1000 only 10 people have cancer. So 99% data belongs to healthy and 1% data belongs to diseased, right? Now in this case, if your machine learning algorithm is predicting everyone healthy, still it is 99% accurate. And though you are getting 99% accuracy, but that accuracy of no use. That is also a problem. Make sense? Right? So these kind of difficulties, these kind of challenges we face while we build some software or tool. And again, the interesting thing is every project, every data set will come up with the new problems and new difficulties. So you won't get bored with the same kind of problems. We need to balance the data. We don't need 100% healthy. We just need to balance the data so that we can detect in an efficient manner. Right? The interesting thing about the data science is every data set, every project will come up with new challenges, new types of problems, and new types of difficulties. So every day we are going to sleep with new problems. Right? That's the interesting part of data science. The positive side of this is you won't get bored of doing the same thing for years. Yes. And you will get midnight thoughts for the possible solutions. What things we can do to get it done. That's what we experience actually. We get the best solutions as a midnight thought when we are not working. True, true. So when you'll start getting the new problems, you'll forget the usual problems, day-to-day problems. When we start getting new and interesting problems, we won't take care about what we are facing daily. Awesome, guys. So I hope this was informative, right? And that was the introduction only. Gradually, we will get into the more technical aspects and we'll start coding, mathematics. Everything is on the table for the upcoming sessions, right? Awesome, guys. I'm glad we enjoyed. We should enjoy the learning. It should not be. We should not feel this learning as a burden. That oh, it's 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 going to be 8 p.m. and we have to attend a session. We should be excited. Okay, no, we are going to learn something new. We are going to have new problems today. So we should enjoy this, right? Awesome. Thank you, guys. Thank you, everyone. Thank you all. Let me know if there is any question, or else we are good to drop off. Case study, will be doing case studies as we reach to the algorithms. Okay. We'll be doing the case studies. Your disk is almost full. Oh, I need to get it sorted for one time only because I can't keep on deleting the things. Okay, guys, that's it. That's everything. Bye bye. Take care. Will you upload the PPT? Is already available in the LMS. You can download the PPT from your LMS itself. Whatever we discussed today, that's already available in LMS. Okay, so you can just download it from there. Thank you, guys. Thank you, everyone. See you tomorrow. Bye bye. Take care. Stay safe. Good night.
Thank you for the wonderful session, sir, and thank you everyone for your participation. Once we wrap up the session, you will see a feedback survey form in your browser. If you like the session, please rate us 5. For anything less than 5, please share your comments to help us understand what went wrong. It will help us to improve in the upcoming session. Thank you all for your time. Take care.